Alright, real life problems here. Modeling linear functions. I'm going to do the first two. I'm going to leave you C. First two are A and B. And we're going to be doing that with y equals mx plus b. And we'll go from there. We'll limit the domain if needed and graph, and hopefully you'll remember this from Algebra 1. But let's read it. So I can model a linear function. This is a review. Recall that when a real-world situation involves a constant rate of change, that's what slope is. I'm gonna write m up here, but it's slope. A linear function is a reasonable model for a situation. Situation may require restricting the function's domain. May. All right. So to write a function that models the given situation, determine the domain of the situation, graph the function using the domain, and identify the range. All right. Joyce jogs at a rate of 1 mile every 10 minutes. And I'm just going to look down here, and I'm going to see that the time is my x, right? So time is generally independent. So I'm going to put x over the minutes, and looks like my miles, my y. Alright, that's usually the dependent variable. I'm just going to put that there. And she does it for a total of 20 minutes. So I've just limited my domain, right? My domain can now go to, I'm sorry, I should have said 40 minutes. Alright. So use inequalities for domain and range. Right down here is when we're saying it, so I'm going to do it down here. Alright, so here we go. Here we go. Identify and define the independent and dependent variables. So the independent variable is time. I can either put that as an x or a y, or t, sorry, as an x or a t. Let's go ahead and make the independent variable t. And the dependent variable is miles. And we could write that as a function of t. That means the output when I put t in, time in. So the rate of change, so that is going to be change in y, change in miles, right, over change in x, change in minutes, right? Let's call that slope, and it looks like it's 1 mile every 10 minutes. So my change in mile is 1 mile. My change in minutes is every 10 minutes. There we go. I'll say delta y over delta x. We get used to seeing it like that. It says find the y-intercept. Well, the y-intercept's kind of easy because before she starts jogging at 0 minutes, she hasn't gone anywhere. So we're going to say 0, 0. Now we're going to write a function, right? We know our b is 0. We know our slope is 1 over 10. So I'm going to write it like this. I'm going to say, right, a function related to time. Notice what I wrote when I said that. I said f of t. We realize that the output is going to be miles, but it's a function of time, right, is going to be my slope, 1/10 times the amount of time, right, plus b, which I'll say is plus 0. You obviously don't have to write that. Alright, so let's graph it. Right? I'm going to graph it by knowing this point, and I'm going to plug in 40 because that's how long she goes ahead and jogs for. So I'm going to say f of 40 is equal to 1/10 of 40. I'll go ahead and say plus 0, but we don't need to, right? And f of 40, so when I plug in 40, I have gone 4 miles. So I've got 40 and 4. She does jog for 40 minutes, so I'm going to use a solid circle here. She didn't start jogging. She actually was at 0, 0. So I'm going to connect them between there. And let's talk about domain and range. So I'm going to come over here and my domain. Let's do it in interval notation. Domain. Looks like it starts at 0, goes to 40. So I'm going to use brackets for both ends. Goes to 40. Just like that. And my range looks like it also starts at 0 and goes up to 4. From 0 to 4. And there we go. We've got it. We're going to do one more together. Alright. So, candle burns at a rate of 1 inch every 2 hours. So down here we have time. That's going to be my input. I'll put an X there. That's my input. And my height is going to be my Y. I might change that. I may make this a function of time, because it is. So use interval notations. Let's write this. We got a function of time is equal to, well, my y-intercept is my start. That's going to be my starting height, which looks to be right here. A candle is 6 inches, so my starting height is 6. And my slope is going to be change in y, inches, over change in x, height, change in, right, output over input, right, however you want to do it. And it looks like I change 1 inch every 2 hours. So there's my slope. So I'm going to write it. A function of time is my slope, 1 inch every 2 hours, multiplied by how much time takes place, plus my y-intercept, which is 6. I wrote that kind of bad. That should say plus 6 down here. Alright. It looks like we go for a total of 5 hours. So we know our y-intercept is 6. Let's see where we're at 5 hours. I'm going to say a function of 5 is equal to 1/2 times 5 plus 6. Right? This is 2 1/2 plus 6, or, oh, am I going the wrong? You know what I did wrong? Hopefully you've caught my mistake. Alright, I'm going to erase this part and I'm going to add something. The candle's burning, isn't it? So instead of being a positive 1/2, it's going to be a negative 1/2. It's getting smaller. So this is negative 2.5 plus 6. So after I've been burning for 5 hours, I'm at 3.5, 3.5. So we'll go to 3.5 right here. It looks like they touch both. It definitely was 6 inches tall, and it definitely burned for the full 5 hours. So we'll get our domain. Domain is how long it burned. It started burning at 0, and it ended burning at 6. We'll get our range. This is a little backwards because you got to get the smallest part. The shortest this candle is 3.5, 3.5. So it's a little small to big. The biggest, the largest it's been is 6 inches. And there we go. Give this one a shot. Talk it over with your table tomorrow, and we'll see what you got.